The purpose of this video is to teach those of you who can't break your MATLAB habit how to use your MATLAB M files or other MATLAB code within LabVIEW. LabVIEW has built in a fairly effective method for reading these things. They call it MathScript, and it's basically just the language that MATLAB uses. As usual, we'll begin by creating a new virtual instrument. Here's our VI. Let's go with the block diagram first. You can either write your MATLAB code directly in LabVIEW, or you can create it inside MATLAB and then import your M file into LabVIEW. Okay, to find the script, let's right-click. You can search for it, but I know it's in the structures, and it's right here next to the formula node is one called MathScript node. Important note on MathScript is it only works in the 32-bit version of LabVIEW, and it requires the real-time version as well. If you don't meet both of those qualifications, you will not be able to get your MathScript to run. Okay, here we have our MathScript window. I could just start typing my MathScript right in here, but what I'm going to do is import an existing M file. I will right-click, go down to Import, and the one that I have is called E80FRF for frequency response function, and there we have imported the MATLAB file. Resize that a little bit so that we don't have too much going on here. You can see that there are several variables here, number of points in the FFT. We've got something called data. We've got a few other functions in here. PSD uses the p-berg method of fitting data to power spectral density, and we have an output here called FRF. If you'll notice, there are 3 red X's here. Those X's indicate places where it is expecting either an input or an output variable. First one we've got here is data. So we will right-click over here, and we will create an input. This is where we're going to input our data. And I will type data there, and you'll notice that now where it says data, the red X's have disappeared. This one here, the red X, has this grayed out thing that says order, and that is the order, or if you will, the number of sections that we're going to have in our fit. And again, I will add an input and type order on that. So now the red X's have disappeared, so I have the 2 required inputs, and it's fairly smart about figuring out what you need from your M file. We will also need an output, and I'm going to click over here. It says add output. Now notice that it lists all of the output variables that I could possibly put here. The one that I'm interested in is the FRF, so I will put that there. And notice it's already highlighted it as being an array sort of thing. Okay, so now how are we going to get our data in here? As we did in our very first project, we're going to read it in from a tab-delimited spreadsheet. The icon has changed from the last time we did this, and here it is, read delimited spreadsheet VI. We will put that right there, and as before, we can connect right there. If we wanted to look at the data to make sure that they were okay, we could create an indicator right here to show what data we got from there. Okay, order, we need to indicate the order. I'm just going to create by right-clicking control, and it's already pre-named order, so I think we're in pretty good shape there. Okay, there is most of what we need. Just because I like to know about these things, I am going to create an indicator for my errors in case anything goes wrong with all that. Not absolutely necessary, but a nice feature to have. One of the things that happens in this FRF that you may not be aware of is these are all calculated as complex numbers. Sometimes there will be a small bit of imaginary part there, and we want to get rid of that, so we could either take the real part of everything, or else what we're just simply going to do is we're going to take the absolute value. So we will right click and get our numeric absolute value function here, and this will take the absolute value of everything that's in there. Okay, so now we might want to check and see what our FRF data look like after we've done this. So again, we will create an indicator here. And we will entitle it FRF data. So far, so good. So let's go to our front panel. Control E is the usual way. And we can see that we've got a few things here. We probably want to make this front panel a little bit bigger than usual, so that we can fit everything on here that we're interested in. So we'll stretch that out a little bit. Order, let's set the default to be 200. Data operation, make current value default. Again, right clicking on there. My error code, I can stick that down here in the corner someplace. It's not terribly important. My FRF data, I'm going to be mostly interested in the frequency and the FRF thing, so I'll just look at the first two columns of it, which I can tell again by looking back there. We will probably want to display these data, and so again, XY graph is probably the easiest way to do it. I should title this and put units on there. The units for this are fairly sophisticated. You may have to do a little bit of thinking to find out, but I should change both this time. I'll at least change that to frequency. And you would want to put units on that, and then the magnitude, and we'll call this the FRF. You on yours might want to make these a little fancier. Okay, going back to the block diagram, Control E. Here is our FRF, and as before, we need to have a bundle of our X values and our Y values. Reading through our code, it looks like the frequency is the first array, and the FRF is the second array, or in LabVIEW parlance, the 0th and the first. So as we often do, we will right click and get our index array section here and start with our absolute valued function there, and we will need two of them, the 0th and the first one. As before, we will use the disabled context create constant. That will be our 0th, just as we like, and this one we will create our other constant, which will be our first one, like that. As before, we could look at the help to remind us that to do this, what we want to create is a bundle of the X values and the Y values, or in our case, the frequency values and the FRF values. So bundle, again, if we go here, we find it's in the cluster class invariant palette, and it's cleverly called bundle. So we have that. And at this point, we just have to have our frequency values and then our FRF values and connect that into there. Okay, so that was basically all we have to do. And Control E to look at our front panel again. We can now run this. It takes a bit of a while to run. Let's go ahead and run and see if we can find. First time it will take a little bit to come up. Here is our E80 sample data that we're going to run. And so we will click that. It will think for a while, and eventually we will come up with our FRF plot, assuming that the code can execute and go all the way through. It does take a little bit of patience, and And I could probably start singing a song or doing a tap dance, but you would not see the tap dance, and I'm sure you would not really appreciate the singing. So we will wait a little bit and see if this comes up. Oh, here our values come up, and there our plot comes up. It will run a little bit quicker the next time because everything's in order. Let's try it with 300 and look how that goes. And again, we'll look at our E80 sample data, our tab delimited text file, and see if this one comes up any quicker.
And I think it's gonna be a long, long time. The touchdown brings me round again to find I'm not the man they think I am at home. Oh, no, no, no.
Oh, it's so much fun waiting while the machine calculates. Let's see what happens. Of course, you can do the same sorts of things using LabVIEW's built-in functions, but some people get very addicted to their MATLAB. Okay, there are our values, and we can see it's changed a little bit from the first time. So there you have it. Just to recapitulate, you put in the MathScript block, you can type in your MATLAB code there, or you can import it from an existing M file. You have to make sure that you have your input variables, and you can tell by looking at the red X's over here. You can have as many output variables as you want. They will ordinarily be typed, and then you can do whatever whatever LabVIEW processing you want either way on that. So there you have it, an easy way to use your MATLAB code inside your LabVIEW.